Our next speaker will be Przemysław Powrotin, and Przemysław works as research engineer at Allegro.pl, and his presentation is entitled Many Shades of ML at Allegro.pl, NLP, Vision and Ranking at the largest Polish e-commerce marketplace.
Hi, thanks for having me. My name is Przemysław Powrotin, and as I was introduced, I work at Allegro as a research engineer. And today I want to tell you about some of the most interesting projects we do across the board here at Allegro, and show you how intertwined production and research models are at Allegro, and how one informs the other and vice versa. So as a brief intro, I guess most of you would have heard of Allegro, as said in the introduction, the largest Polish e-commerce marketplace, and in fact the 10th largest in the world. So here on the slide I gave you a few numbers to give you a sense of a scale that we operate at. And obviously operating at such a scale presents many challenges that are best tackled with machine learning. And I want to talk about these challenges through the lens of the life cycle of a product on the platform. So obviously the product needs to be first listed on the platform by sellers. Then we need to provide means of finding these products by our customers. And finally, once hopefully they find and purchase what they're looking for, we provide post-purchase care and support through our customer service or customer experience team, as we call it. So by looking at each stage of this cycle, we'll zoom in and see how machine learning can help with various challenges and pain points that we observe throughout the cycle. So starting with listing an offer, that sounds easy enough. Either using a form to fill in or an API, a seller is able to list his or her offer, filling in a title, some attributes, a description, giving a nice image. So it sounds easy enough. However, there's one catch. So as you see on this screenshot, which sadly isn't published, but it's from the actual site, when an offer is being listed, we suggest as a platform a product to match with that offer. So what is the distinction between offers and products? On the left, you can see so-called offer-based view of a search results list, and on the right, a product-based view. So in the offer-based view, each individual item on the search results list is an individual listing by a distinct seller. So in particular, many different sellers can try and sell the same item. And this creates extra cognitive burden for our customers when they're trying to look for products, because ideally they would like to first browse what products are available on the market, and only afterwards, once they decided on a product, look for the best offer of that particular product. And this is what's available in the product-based view, where we first group all the offers of the same product together, presenting a cleaner, more streamlined view for the user. So in order to be able to transition from the view on the left to the view to the right, we need to be able to match offers with products. And one point of matching is once an offer is being listed, and another is we have plenty of offers which already are on the platform, and we need to match them once they've been listed. So you can think this is an easy enough problem because it's just a classification task. However, you have millions of products, and the list of products is expanded pretty much daily with new products. So you do not want to train a classification model every single day onto millions of classes. That wouldn't really be sustainable. So instead, we decided to go a metric learning way. Roughly the way the system works is you have your both offers and products represented textually as their titles and concatenated attributes, which are key value pairs, for example, a screen size and the value of that screen size, etc. Then we can encode these textual representations into a common vector space using any textual encoder you can think of, and we obviously use a BERT-based encoder, as BERT is king these days, and we use our own variant called Herbert, which I'll come back to in a second. And then we can fine-tune these embeddings using triplet loss, so a standard metric learning approach, where as an anchor, you take an embedding of your offer. As a positive example, you take an embedding of your matching product, and as a negative example, you can take an embedding of your non-matching product. And the triple loss is so that you want to bring the anchor and a matching product closer together in the embedding space and push the non-matching product further apart, in fact, further by a margin M, which is a hyperparameter. And once you fine-tune the entire system, both the encoder network, the BERT-based encoder, and however many like fully connected layers you stack on top of that, you end up with your matching system, which is able to match offers with products. So this project started off as a project very much requested by the business and meeting kind of business needs of our platform, but ended up being described in the research paper, BERT-based similarity learning for product matching. This paper has recently been accepted for presentation on the Calling workshop on natural language processing for e-commerce. The workshop is due to take place in December this year. The paper is not yet on arXiv, but stay tuned if you're interested to read the details. In particular, we go on in a bit more depth into how to best create the triplets for the training procedure, because if you've read any metric learning literature, you know that the way you create these triplets very much informs the dynamics of the training. And also there was a talk by my colleagues from Allegro, Kalina and Bartek, yesterday about their research in the best strategies for creating such triplets. So as I mentioned, we needed a BERT-based text encoder that would work for Polish language. And at the time, none of the available models, say on Hugging Face, were good enough for our needs. So we decided to create our own general purpose Polish language model based on BERT. And one factor that was driving the research in language models in in English, were the availability of benchmark datasets, or other collections of datasets called glue and superglue. So these kind of leaderboards allow you to very quickly check your model against a bunch of standard tasks and compare it with other models, so that you know whether you're making progress or not. So we wanted a similar sort of leaderboard for Polish, so that once we would be experimenting with various hyperparameter choices for our BERT models, we would know whether we're actually increasing their kind of modeling capacity. So since there was no such benchmark available for Polish, we just made one, and we dubbed it CLAY. It's a tongue-in-cheek name because CLAY is actually glue in Polish, but it also stands for Comprehensive List of Language Evaluations in Polish. We're very happy that this benchmark was very quickly adapted by the Polish NLP community. In fact, our model, Herbert, is currently ranking 10th, but we're working on improving on that and releasing the second version of it. The CLAY benchmark consists of a number of tasks which are already present in the literature, and an extra new task, Allegro Reviews, where the model needs to predict a review score of a product from Allegro platform. And again, this work, which started to fulfill our internal production needs, was described in the paper CLAY Comprehensive Benchmark for Polish Language Understanding, which is available on arXiv. It was published at the 2020 ACL conference, and you can also use the model itself, the Herbert model, because in the paper we describe both the benchmark and our BERT-based Polish model called Herbert, and you can use that model with a, I think, Creative Commons license from Hugging Face. You can download it from Hugging Face. Okay, so once we have our products listed on the platform, obviously the heart of any e-commerce platform is a search engine. So it's an obvious way of finding your products. And obviously Allegro does have a search engine, and I could go on at length on how it's designed, but for any search engine, the final stage is the ranking system. So a ranking model is a machine learning model which learned on the past interactions of the users, takes in as input a group of items which are a list of search results for a given query, and sorts them, or provides their scores, which then can be used to sort these items in a group in a way which will maximize utility of the user. In other words, the item that, or the group of items that the user is looking for will be closer to the top of the list. We do have a ranking, machine learning-based ranking system in production, and you can hear more about it in some of the previous talk we've given that are easy to find on YouTube. But today, I want to say a few more words about some of the recent work we've been doing on developing this ranking system further. So the current ranking system is based on gradient boosting algorithms, in particular on XGBoost. And XGBoost is well suited for tabular data, but it's not that great if you're working with other modalities like text or images. And we were thinking about how to include text and images, so title and description and an image of an offer as signal into our ranking models. And again, we resorted to metric learning, where this time as our anchor, we take the query of a user, so text that the user put in the query box, in the search box. As a positive example, we take either title or an image or some other way of describing our offer. And as a negative, and we do it for the offer which was clicked for that particular search. And as a negative, we pick the same modality from an offer which wasn't clicked for that search or comes from an entirely different search altogether. And then again, we fine-tune these embeddings using triplet loss, so that we obtain a kind of common vector space where we can embed search phrases and various modalities describing our offer. And then distances or similarities in that vector space can be used as features in our ranking system. But this prompted us into thinking that this whole system isn't very scalable. It's a bit cumbersome because the ranking model is gradient boosting and you can't optimize the whole thing end to end. So we started investigating whether we could use a neural network as a ranking model and optimize the entire system end to end. And at the time, that was actually more than a year ago, when we first started thinking about these ideas, the kind of common thing in literature was if you wanted to use a neural network as a ranking model, would be using a fully connected network. And as we tested them, we found out that they weren't quite making it for us. And we decided that perhaps we thought that perhaps the problem is that in ranking, you're actually interested in scoring a group of items simultaneously. But by using a fully connected network, you only take one item at a time. So what's the hottest new model that everyone uses when they have a set of items to score or encode? Obviously, it's the transformer, as pictured on the left here on the slide. So we also conducted a research project in applying transformers in learning to rank setting to quite a good result. In fact, we've beaten state-of-the-art results on a benchmark dataset for learning to rank called Web30K, which comes from Microsoft. And you can read more about the results of that in our paper, Context-Aware Learning to Rank with Self-Attention, which was published at this year's SIG-IR workshop on e-commerce, in fact, as a contributed talk. And as a part of that effort, we open sourced our library AllRank, which is a PyTorch-based library for neural learning to rank. So if you're interested in this sort of applications, do check out our code as well. So we have our products on the platform. We have a way of finding them given textual queries by users, but some items are very difficult to describe in words. And it would be nice if you were able to just take a picture of an item and find it via picture. And this is a feature we've been working on for quite a while now. And it's been as we speak, it's being rolled out to more and more users. So if you're actually lucky, you might be one of the early adopters of that feature. So the rough sketch of how one can design such a visual search engine is you have a user taking a picture, which is then vectorized with a CNN model. And then we want to find the nearest neighbors, so the other offers which are most similar to that picture, that user's picture. So to that end, we need the FICE index, so an approximate nearest neighbor search index, where already all the pictures of all offers available on Allegro are pre-vectorized with the same model. Then we conduct the nearest neighbor search and serve the results. That sounds simple enough. It's actually not that trivial to make it work robustly in production. So to go on into a little bit of more details into how we designed that visual search engine, is that first of all, we need to somehow create a data set of, again, we again, as in the previous projects, we resort to metric learning approach. And again, we need to be able to create kind of triplets of images based just on the images we have on the platform. And the difficulty here is that the images on the platform are mostly studio quality, whereas images people upload in the app are kind of taken by their cell phones, and they're not necessarily the same quality or good pose or lighting, and they have a background, whereas most pictures on the platform don't really have much of a background. So we spent quite a bit of time going into how to construct such a data set, and this is like a topic for an entire different talk. But once you create your label, your kind of appropriate data set, you go with the standard metric learning route of using your favorite CNN to encode these pictures. Then, in fact, through experimentation, we found that triplet loss in that case is best swapped with something called large margin cosine loss, which you can think of like a ranking loss on a batch of items. Excuse me. And then we found that also, because we wanted the model to serve the entire fashion category, but we don't want to suggest like a dress if someone's looking for something that's clearly, say, a male shirt. So we also added a classification head predicting the category of an item. And then we mix the two with weights which are learnable. So instead of setting by hand the appropriate mixture of the two losses, we allow the model to learn it itself. It's a trick from a paper I'm quoting on the slide. So this is very roughly how you can go about designing such a system. And at the moment, we're working on extending it to work for other categories to serve in the end most of Allegro, wherever search engine is visual search engine is applicable. And finally, once customers find the product they're looking for, be it through text or visual search, they hopefully purchase the product they were looking for, but every now and again they need some help. And to help them, we have the entire customer experience team with dedicated specialists who answer, for example, emails coming from our customers. And there's quite a lot of these emails passing through our CRM daily. So we started thinking whether we could somehow alleviate the burden of replying to these emails and perhaps automate at least part of that. So the way we went about that is, if you remember, I talked a few slides ago about our own internal, or in fact, open sourced Polish language model, BERT. So we took that and we fine-tuned it on the corpus of the emails exchanged between our customer experience team and our customers. And in the fine-tuning, we obviously use the masked language prediction objective. But also in your kind of usual training of BERT, you also have the next sentence prediction objective. We're given a pair of sentences. You want to predict whether one is a consecutive of the other. We swap that for what we dubbed a next email prediction, where given a thread of emails, you want to decide, or rather given a pair of emails, you want to decide, do these come from the same thread, kind of email exchange thread or not? We fine-tuned this model, obtaining a new kind of BERT model called MailBERT. Obviously, for obvious reasons, it's not externally published. And how do we use it then? So we can obviously embed all incoming emails using that model into some common vector space, but doing so, we just obtain some unlabeled points in the vector space. However, by looking at the kind of historical data and the responses that were given to these emails, we can identify fairly easily, based, for example, on reusable templates, at least some partial labels in our data. And then we can, again, resort to metric learning using these partial labels to fine-tune our embeddings. And in fact, we do it not based on the embeddings of the emails, but on the embeddings of the answers to these emails, because the answers are usually written kind of using a similar professional language, and they're much easier to cluster together, turns out. So you fine-tune your mail BERT using this partially labeled data, and once you fine-tune them, you can do your regular old k-means clustering on these answers to emails. And not only do you recover the labels you already had, but what's most important for us, you in fact discover new clusters, new kind of intents that people are writing with. And having these intents, we can just create like a labeled data set for classification of mails and the intents of these emails. We train a kind of further fine-tune the model to serve as a classifier for that purpose. And then we can create templates for these intents which are answerable via a template, hence simplifying the work of our customer experience team. So these projects that I gave a very quick bird's eye overview of are just a tip of an iceberg of the projects that we currently work on and we're planning on working on. And some of the ideas we'll be looking at, or we're looking at already, are chatbots for customer support, extending visual search to serve any type of product, not just the fashion category, personalizing our ranking and recommendations, which I haven't even touched upon, but obviously we do have machine learning models for recommendations, and we want to make them much more personalized and session aware. We want to finally bring to production our neural ranking project that was started off as a research project, or optimize how we appear in Google search results using machine learning. So these are some of the ideas we'll be looking at in the near future. And if you're interested, we're always looking for research engineers. So as I mentioned, we have projects in NLP, vision, ranking. We're also looking for people with expertise in reinforcement learning. So if you're one of these people, do hit us up. One thing worth mentioning is that 20% of our time we can spend just doing pure research. We have weekly research seminars. It's okay to attend top ML conferences if you want. There's a conference budget you can use, which is quite generous. So yeah, if you have any questions, I'm happy to take questions now, or feel free to email me at przemysław.fabrotin@allegro.pl. And there's a link here at the bottom of the slide if you want to apply to join us as a research engineer. Thank you.
Thank you, Przemek, for this comprehensive talk on how Allegro is spiced up with machine learning. It was really interesting. And now we can finally begin the Q&A session. And we have two questions from the audience. And the first question is, how is the new version of Herbert going to be better?
So that's a very good question. I wasn't part of the team that was actually working on it, so I don't know all the details on top of my head. But I think it was a more careful choice of hyperparameters, larger training corpus, and a kind of more thorough ablation study of the effect of various hyperparameters on training performance that allowed the guys to kind of better their performance on the benchmark, on Clay benchmark. I think that was roughly. But if you're interested, just kind of follow us on our social media, and as soon as the paper will be out, like you'll get to hear about that. It's still work in progress, but it should be out fairly soon, I think.
Okay, cool. Thanks for the answer. And the second question is, how would you tackle the problem of locking users in information/content bubbles?
I'm not sure I understand how that pertains to Allegro, but I suppose it might be a problem of recommendations.
Yeah, I think that this is the intent of the question.
Yeah,
actually.
yeah. So it is a very difficult and open problem, and I can't really say I have an answer to that on top of my head. But this is something that will definitely be we'll be aware of and we'll be looking at once we focus more of our efforts into personalization at the platform. Definitely.
Okay. I would have like one more or maybe two questions from me. So the first would be like you said that you are like deploying the visual search functionality for some of the users. So is there any initial feedback from them? Have you heard anything good or bad regarding this feature?
The feedback is being collected, obviously, but I'm not sure I'm allowed to share it yet.
Okay. That's okay. I understand. Okay, so I noticed yesterday that during Patrick Miziła's talk, one of your employees, Bartosz Ludwiczuk, was very interested in that talk. And this talk was about intelligent close swapping. Do you maybe plan to launch something like this in the future? Or are you also not? Okay.
I'm not allowed to
Okay.
comment on our
Okay.
future plans regarding
Okay.
possible
I
product
understand.
launches, I'm afraid.
So I guess that will be all as it is for the Q&A section, and we will now proceed to the next presentation. So thank you, Przemysław,
Thanks a
for
lot.
the presentation and for the answers.